Hi everyone, my name is Thomas Kim. Today is July 25th, 2021. This is 36th episode about modern C++ experiments. I will discuss the problem that had haunted me for several years while in college. nCr, the number of combinations. From our previous episode 35, we learned how to implement npr. We gracefully handled integer overflow using std optional. If you haven't watched my previous video, please watch it. In the download source code section, double-click this link. Show in folder, extract here, rename 36. Copy the folder path, copy, paste it in your working directory. Now start Visual Studio Code. From folder 36, open nCr npr, open npr.cpp, Ctrl B. We need rational number, cpg rational.hpp. We will create namespace alias, namespace crn, cpg rational number. Now scroll down. We will implement the number of combination or nCr unsigned long and unsigned long r, std optional unsigned long result, initially uninitialized. Let me describe our problem. We have a set S with 0, 1, 2, 3, n minus 1 in total n distinct elements. From set S, we select all elements without repetitions. The number of unique selections is called R combinations of n, or nCr. In North America, this is often represented nr. We cannot compute nCr directly. Instead, we use nCr. We selected all elements. Now times r factorial. It is equivalent to n permutation r. From this, we can represent nCr npr over r factorial, or it can be represented n times n minus 1 times n minus r plus 1. In the denominator, r times r minus 1 times 1. The last part can be represented like this: r minus r plus 1. So this part identical. Also, it can be represented n minus 0, r minus 0. From this, we can represent. I will copy this part, paste. I will remove and arrange like this. In this configuration, 0, 0, 1, 1. This can be represented r minus 1, r minus 1 like this. So k runs from 0, 1 to r minus 1. From 0, 1 up to r minus 1. 0, 1, 2 up to r minus 1. In simple mathematics, nCr equals nC n minus r. From this, we can let r minimum r n minus r because nCr is symmetric with the center element. Also, nC0 nCn equals 1. If r equals 0 or r equals n, this condition r is either 0 or n, then 1. Result 1, return result. If r greater than n minus r, we are using this equality. R equals n minus r. Now, CRN, rational, unsigned, long, old value, CRN, rational, unsigned, long, new value, bool, success, true. For unsigned, long, k, 0, k, less than r, plus k. We are using this condition here. In this loop, r is not included, but r minus 1 is included. So, the range of k is 0, r. 0 is included, r is not included in this configuration. Now, we use this term. Each term forms a new rational. Here, auto value CRN rational. In this equation, 0, 1, r minus 1 is k. So, n minus k over r minus k. n minus k over r minus k is term. Old value, we save new value to old value. Save new value to old value. New value multiply equal value. This value. Or we can bring it cut here. It doesn't matter. If old value is not equal new value, we perform reverse operation. Value here. It means overflow occurred or operation failed. Success, false, break. Out of the loop, if success, true, result, new value. Now return result. Now scroll up. In our previous episode, we created test permutation. Now copy, paste it here, test combinations. Everything is the same. Now this is nCr. I will delete this. Also this nCr, nCr. Now here we can say n over 2, because nCr equals nC n minus r, symmetric. Now scroll down, copy, paste, disable it, test combinations. We are calling this function. This function calls nCr this function. Now in the command prompt, clehsc sed c++ latest npr.cpp fe m.exe, hit enter. clsm. Something wrong. Every elements are 0. It means I failed to initialize. The default value for new value, it should be 1. We build again. clsm. Now it seemed working properly. Control Home, Combination Calculator, Control click. I will arrange side by side. We select anyone. 39, 7, calculate. This is the result. 39, 7, 15, 38, 15, 38, 37, 37, identical. Now scroll down, 60, 30, 60, 30, calculate. 60, 30, 1182, 1182, 1424, 1424 exactly matches. Now scroll down, 117, 117, calculate. 117, 66, 50, 66, 50, 1800, 1800. Our algorithm works correctly.